just quick introductions. So I'll just go first. I'm Chris Katoya. I am Executive Director of the cadcad Foundation and product lead at Block.Science Labs. So I'll be excited to talk today about all the developments that are happening in the cadcad ecosystem. Who'd like to go next for an introduction? Maybe Yenti. Yeah, NTT's been a great help and awesome. Yeah, maybe a manual if you're able to.
Yeah. So my name is Emmanuel Lima. I am the lead engineer for cadcad refs implementation, and I work at Block.Science as a software engineer, mainly focusing on like performance engineering of cadcad and scientific computing libraries in general. Yeah, that's pretty much it.
Awesome. Who'd like to go next?
Hey, Brock, and computer engineer, startup in like a Web 2 startup in real estate space, and trying to make sense of Web 3 and just in general, like cognitive modeling, stuff like that. And so that's kind of how I found my way here from Active Inference Lab, and so I'm kind of interested in just general applications of cadcad and using it to, just find better architectures for different use cases. And so happy to be here. Yeah.
Awesome. It's great to have you. So it looks like we have Ali and Mount Manu.
Hi, I'm Ali. I'm an independent researcher from Iran. I've been a big Julia fan for a while. I can't really call myself a professional Julia developer, but I'm just trying to do my best. And I've been acquainted with this channel through Active Inference Institute, and I'm pretty excited for this announcement here. Thanks.
Awesome. That's great. Great to have you. And Mount Manu, and I guess then we can just get right into things.
Yeah, thanks, Chris. Yeah, my name is Manu, and Web3 I go by Mount Manu. You can call me either. I'm also a contributor for Token Engineering Commons. I work with Enti in the communications working group, specifically within the marketing part. And yeah, I've recently started studying complex adaptive systems to address some issues that have arisen in TEC regarding, I guess, exogenous market forces affecting, the contributions or the budget for different people. So I think if we had modeled, we would at least have been aware of what a shifting TEC or ETH or Bitcoin price would entail in terms of the income of the contributors. So that was the the that was why I started studying complex adaptive systems, and they're really interesting. And also I was tasked with bugging Chris until he came into our community calls. So I hope no hard feelings, and I'm happy.
It's all good.
I'm happy to see what I can learn from all of you guys.
Cool, great. Well, welcome to the rabbit hole of complex systems engineering. Cool. Let's get started. I am going to just kick things off. All right. So it's great having everyone. So I'm sure sort of the announcement of hey cadcad Julia brought some folks in today, so that's kind of great to hear. Normally community calls we have a bit more of like a guest presentation talking a bit about um, some interesting aspect of CAD modeling that's happened. This call, we're just going to sort of focus a little bit more on um, the higher level strategy and ongoing cadcad as org. Think of this a little bit as like an Apple WDC sort of like, keynote, like, hey, this is what we're doing at cadcad. So it'll be a little bit shorter. I would love to have a bunch of questions. Hopefully, I'll be able to respond. And yeah, just I think keeping this one a little bit shorter and more informal, I think will go a long way for just making the community better and growing. So there'll be some updates from the infra admin working group, some developments on the bounties program side there. The just a brief discussion of what Cortex been up to, and then the cadcad Julia implementation announcement. So, from the infra and education working group, one thing we want to really kick off is sort of cleaning up the documentation for cadcad as well as cadcad wiki. I had a wonderful discussion yesterday with Brock about this. I hope we can get some people from the community. I don't want to volunteer anyone at this juncture right now, but getting some point people that are like passionate about solving a problem and then being able to support them in any way is sort of the model that we want to take at cadcad. So the documentation is really to help with just onboarding as a modeler or a developer. It's something that's been kind of missing. We've been well aware of this whole and would love support making that happen. And cadcad wiki is an attempt to really just build up the knowledge base and make that extremely available community of so things like control theory, complex systems, complexity sciences, things like that, that really aid in not just the functional how do I use cadcad, but what we've found is people are getting tripped up on how do I decide what to model and how do I go about that? A little bit more of like the art side of the modeling. So we view the wiki as a way of enabling a little bit more of building up the intuitions on how to do that modeling as well. And right now it's like there's a bunch of links and a bunch of disparate different places. And so just kind of creating a central point for people interested and passionate about modeling to be able to sort of collect that and contribute to the knowledge commons. And then the bounties program development. So we'll just get into that. So 2 years ago, we did a trial run of this. We had a contributor named who goes by Dog, DAWG, and Tyler Mace, who's been an active contributor to cadcad, sort of lead the trial run and some development of a process for issuing bounties. And really what we found is that we were spending more time to try to specify and help newcomers complete the bounty than it would have taken just one of our lead technical contributors to just do it themselves. So we weren't getting any like return to scale on time there. And then sort of like moreover than that, people that were a little bit more self-sufficient, they were still starting their journey and like learning cadcad and all this stuff. So it was like they were spending way more time than anticipated. So the pay scales for the bounties were just totally out of whack. It felt a little abusive. We didn't want to continue this. So we basically learned is like, cadcad is just really not in a mature enough state to basically say, okay, there's a pool of contributors that are able to work on demo models or cleaning up the repo and things like that. It was just too early of the project. The community wasn't scaled out enough. And so we realized we needed to like figure out ways of onboarding newcomers and in a sufficiently timely fashion and scale to make bounties make sense, as one point. And then the other point was, just the administration of anything kind of takes time, so it's got to be worth doing it. And it was just complicated by the fact that we were trying to issue bounties in an extremely open way, to basically very unknown audiences. We didn't really there's a disconnect between what was the skills and knowledge base required and where the audience at large was at that point in time to be able to do that. So we kind of, quietly paused on doing bounties as we realized we needed to prioritize other work. As you've seen, we've been doing a bunch of work on cadcad reference, and breaking new ground on other stuff as well, which is what this talks about. So the solution was we needed to reduce the friction in just the onboarding experience. So cadcad references that as a way of just making it easier and more legible to learn about modeling generalized dynamical systems. The current version of cadcad, there's a bunch of gotchas. We're aware of this. That the current version of cadcad is dog fooding. And all of that knowledge base over the past 3 years of developing that from an internal use case at Block.Science to do complex systems engineering on R&D work and client work, it birthed cadcad. They just needed a tool to work. A lot of that tool has tribal knowledge in it, and we are making that tool more easy and accessible to just get started with reference. And that's why reference is taking time. We're actually learning a ton about a lot of hard problems when it comes to ensuring that software does the math you think it's doing. And then also trying to make the UX nice on it. So there's the cadcad reference component of it, of just making the tool easier. Second component is that building up that knowledge base, as I was referring to with the cadcad wiki, to just enable a little bit more self-guided learning. And then a proper doc site and documentation for modelers and developers to get onboarded. The next piece of the solution is scaling and leveling up the community with education partnerships. So we've been doing that with Token Engineering Commons, with the cadcad study groups, and that's ever evolving. We've been doing this. Token Engineering Academy has some cadcad courses. There was also very early on cadcad.education as an effort by a separate entity that was building educational materials on that. And then I'm also in conversation with a few blockchain foundation and improving the quality of their own projects with getting modeling, cadcad modeling as part of their ecosystem and granting process, and they want to do educational materials as well. And so as those things come to fruition, I'll make those announcements in time. They're kind of slow moving though, but that is part of our strategy here. And then the last bit is we want to follow the lead on proposal processes that other projects have done successfully. And so what does that look like? It's, hey, if you're interested in being involved in that, you got to participate in the community and build reputation. Just become a known entity, and then you can draft a proposal, submit it, socialize the proposal, get people excited by it. You can have hard systems in place to measure things out, or you use softer systems of governance of just hey, do you know what this thing is? Oh, I have no clue, right? Or, oh yeah, that's a really cool project. They're doing this X, Y, and Z. So things we'll play with there. But generally, this is the sort of architecture of things. And then your proposals get accepted and grants are issued. So that's more on the proposal side. There's also bounties as well. So some open questions we're still contending with is, do we have applications to join the bounty program as a sort of an identified contributor, that we have a sense of where your skills are at. So we have a sense of where the community skills are at for drafting the bounties and then putting them out for people that are already approved in the bounty program to fulfill on. So this is a way to sort of deal with, the cognitive load of administrating all of this stuff and also ensuring quality and really just growing the community from that. And one thing we'll try to do is we'll start with bounties, just as a way of like one instantiating work to be done on like near term needs, and also as a kind of demonstration for the community of like what a successful proposal will look like, and eventually probably shift over to more proposals as like the community is more involved and it's not just um, a small group of highly involved people trying to drive the project. Um, any questions or thoughts so far? I'll take that as a no. Cool. So the current status of this is where we're at now is Zargum and a few others that are highly involved in engineering commons, as well as other sort of related projects, including NumFocus. They've been designing a bounty and proposal program with TEC and NumPy through the open source grants project. And so they worked out a whole design for applications and forms, and a means by which grants could be issued in XDAI through Gnosis multisig. So that's actually new on, to my understanding, on all fronts for the open source granting program as a whole, which will be really exciting. And so we're looking closely to this upcoming launch, and we want to iterate against any lessons there, and we'll very likely adopt the same, if not a very similar framework. So that's really exciting. We'll finally be unblocked from being able to like issue the bounties that grants that we've raised through Gitcoin, and really get that going. So that's like a huge milestone for us, and once we get that, then like small little things that we've wanted to get done and just be able to incentivize community work against will get accomplished. Cool. Any questions? All right. So core tech, it's been primarily focused on the reference roadmap. There's a few highly technical details in terms of updates that we could cover if Emmanuel feels so inclined. We don't have to, but generally at a high level, blocks and points are still underway in progress, getting increasingly close to wrapping those up, which will be really exciting because then the ability to define and express the models will be sort of fully encapsulated. All the updates are available right now in the repo, which is the links listed at the bottom in one of the development branches. I don't believe it's merged to master. Emmanuel, you can correct me if I'm wrong there.
No, it's good.
Yeah, cool. So then after that, we'll get DAGs of blocks and trajectories, potentially as a class. This may have been updated since last time. And when you have that, you can run models. And then you have basic you have fully functional cadcad. So that's, yeah, we're getting close. It's just really hard going because basically we're making Python do things Python is not originally designed to do. And part of that is our strategy overall is cadcad reference is really meant as a way of starting your modeling journey. We're focused on expressing the models, making it easy to express models and make them legible and modular. And it's in Python because that's sort of the first language that people learn. That's where most of data scientists are at right now. And Python is a very readable language. And so we wanted something that is any encapsulation of generalized dynamical systems in software, we want it to be as legible as possible. Reference as the reason of, hey, any implementation you do in any other language of cadcad, we want to be able to point to the reference implementation as saying, hey, if it can function in the way that this thing does in terms of expressing the mathematical results in a certain way, then it's cadcad. So we're here today because we're talking about cadcad Julia. So it'll be in Julia. The focus of cadcad Julia will be the performance maxing. Maybe I should put 2 X's in there per the meme. And we're focusing more on production-focused applications. So we're going to assume in this Julia implementation that you have an understanding of GDS. You're familiar with modeling. So we're not going to do. So we're going to make trade-offs towards performance versus ease of use whenever those things come up. Generally, on the whole, that's sort of our strategy here. And then sort of soft announcing cadcad Rust. This is not any work has been done on, but we are interested in investigating Rust as another implementation because it gives us the ability to run on a variety of systems, including like via WebAssembly. Once you have WebAssembly, it's like kind of game over in terms of like the omnipresence of what you can run on. And as it's Rust, it's really a way of onboarding systems and embedded programmers. And so it will be bringing GDS and the methodology of that to a much wider framework. Like as we've seen, a lot of adoption of cadcad has been currently in sort of the token engineering ecosystem. That's somewhat of a consequence of token engineering being a subset of complex systems engineering due to the fact that you have loss of conservation and you can observe constraints. But there's broader applications of cadcad, and so being able to have these additional implementations helps us get that out there. I want to take a pause for anyone to if you have questions or thoughts or comments, love to discuss.
Yeah, this all sounds good, and the bounty program approach makes sense. And yeah, I'm not. I guess I would be kind of interested in what the limitations of Python are that mathematically you have are problematic, because that would probably it's
maybe Emmanuel wants to talk about sort of the challenges on reference. That might be illuminating.
Yes. So the main problem with the Python implementation, it's not let's say a problem per se. It is a problem for what we want cadcad to be. Like it's not let's say a problem of the language in the sense that the language is failing or whatever. It's just that the main characteristic of Python as a dynamic language is that its execution time of software written in it is pretty bad. It's pretty big, and we want cadcad in the near future to be able to perform simulations as fast as possible, because that's basically a goal of each and every software in the scientific computing area. We want to produce data, we want to produce results, and we want to finish simulations as fast as possible. And in our case, the product of a cadcad simulation would be the trajectory, for example. So we want to be able to produce trajectories as fast as possible. And because of the characteristics of Python, because of its type system, of its dynamicity and stuff like that, between other things, Python software usually is quite slow when compared to other languages like Julia and Rust, right? So there's performance. And another point is the type safety of what we do with Python. So we want to ensure that modelers have some sort of type safety when writing models, because type errors in Python are very hard to debug when you have very complex software. So we have to remember that not only cadcad is a software because of the library, but the model that the user writes is also a piece of software. So depending on how the user writes its dimensions, writes its spaces, and its blocks, because Python is a very dynamic language, the types of the variables can change. There is no guarantee that the model of the user is going to produce. There's no guarantee from Python itself, from the Python point of view of things, can guarantee that the model is going to produce the correct results, because the types can get confused. You can like the engine, if it depended only on Python, could like mix up the types and Python would not complain, right? So the amount of type safety that we can get from Python is very, very low. And we want to be ambitious to actually get a lot of type safety, and not only for the sake of performance, but for the sake of correctness of models, right? So we are doing the best that we can with the limitations of Python, because the typing library, the typing functions, the functionalities, the typing functionalities of Python, they are something that's very new. They are something that's still getting developed. The typing API is something that is is growing by the minute. So that's why cadcad reference is tracking the latest version of Python. So we are programming cadcad to run on Python 3.10, for example. And we will support out of the box Python 3.11, because we are already anticipating to be using some functionality that is already going to be available only on Python 3.11 that's coming out next month. So we are tracking the latest version of Python because we want to give the users a lot of type safety guarantees that Python has only started to give now. And even though that those APIs for type safety, for static analysis are coming in Python now, it is still very optional. So to use types in Python, and when I say to use types, I say type annotations. To use type annotations in Python is something that is optional. So it's not something that we can actually force on the user, because if the user wants to create his own models entirely on untyped or rather unannotated Python, the user will be able to, because that's valid Python, right? Nothing we can do about it. But from the users, from cadcad point of view, the parts of the model of the user that are going to enter the engine, to enter cadcad, they will have to be typed, right? Because we are doing cadcad as a typed version of Python, and we expect type annotations to inform the engine. So the engine needs that information. So basically, to sum up, the main challenge with Python is performance and type safety and type guarantees that Julia and even more Rust will give us. Yeah. That's it. Did I answer your question?
Yeah, no, that makes complete sense.
All right.
Just as a tangential thought or whatever, I think the typing, if it's I don't know, either you've worked on a project where it was, or you're a mathematician or something, where you get like that strong typing is very, very valuable. That's a hard sell for most people, because it's just like, write more code, it'll be better for you. But on the compute side of things, like now, right, even like recent paper from DeepMind on like compute optimal training models, like that like it's just having a bigger data model is not going to work. You're going to need more compute to have these sort of optimal models. Like that means that your compute time is now like a huge factor, in shaving 1% or 20% or whatever off, is really going to make a difference. So I don't know if that's, an adoption, selling point. It would seem to me like if it's, faster, in other words, right, then, I mean, it seems like something that's going to be important from it's like a corporate budget standpoint.
Yeah. Yeah, and then there's a very interesting point there. Like we anticipate that if a cadcad reference user has never used typing before, like I think most data scientists don't use, or maybe I'm wrong, but I think at least from my a small universe, my biased universe, most of them don't use typing. They just use Python without any type annotations. They just want the results. So there is going to be a learning curve because for most of the model, cadcad is going to expect type annotations in order to work because cadcad needs that information. So there is going to be a certain learning curve, but we expect, because the amount of typing that cadcad wants is very specific, not that big. It's just on very specific parts of the engine. So we think that learning curve is not going to be very steep.
Yeah, I guess also too, it's like the system modeling you're doing is not really like machine learning in the way that I think you were referencing before. Like, so I think the applications are a bit different. I did sort of see discussions of exactly what you're talking about, and it's just like at the scales that you have to do the sample data is astronomical.
I mean, I think in Web3 though, it's going to be the same story. Where if you want to simulate these sort of tokenomic systems, like only so much data is going to be helpful, and then your compute will be the bottleneck. So
yeah. And then I guess sort of the other aspect of it too is that what we're really trying, like the real aims of reference is to help people build the sort of the abstraction of the data model of what a GDS model is, right? And the problem that we've observed with the current implementation of cadcad and 428 is 0.428 is that it's very obscured and a bit obtuse on that front for people that are like just trying to learn this thing. And so like in the help channel that you see is like some of the problems are just dealing with like the weirdness of however it was implemented, but also just like that there's oftentimes you'll see that there's really a frustration between us and the software. And so what we found is like, foolishly, we thought reference was much faster than it's turned out to be. And what that's actually benefited from is the fact that we've uncovered all of the actual hard, difficult problems. And so what we're starting to realize is like, hey, you know what? Even though it's taken almost 10 times longer than what we anticipated, most of the problems that we're dredging up now are really ways of like the design problems that are going to reoccur in a Julia implementation, in a Rust implementation, in whatever other future implementations may exist. Because there is a Rust version of cadcad that exists. It's called radcad, that Ben Schultz, who is super active on the Discord and extremely helpful to people. I've seen him help a few people on the call that he's worked on the side. It still runs into, but because its lineage is from the current version of cadcad, it still runs into very similar, maybe we call them ontology issues of like people getting into this thing and then sort of realizing that like they don't have the mental picture yet of what the model is, and how to translate the model, the thing you're trying to model, into the software. So that's really where I see a lot of the typing work coming into play. Is like it's trying to marry these two concepts and sort of bridge the gap from a mathematical construct into software. Cool. Any other thoughts or questions? Cool. All right. So, Julia, So in the Discord, we made the announcement that we opened up the repo. It's work at Block.Science. And so why do we make this public? Why are we having this call right now? Well, we started finding people were interested in joining the core tech team and just actually cadcad more generally in order to work on this implementation. And we were really excited because being able to break ground on this helps us grow cadcad and actually support development on cadcad reference. One thing I've been sort of raising the issue mostly, but we're keen on trying to onboard additional people that have a fresh set of eyes as a way of sanity checking the current reference work. And we're basically now at that point of trying to start onboarding technical contributors. And the best way to probably do that is actually showing the constructs and concepts in reference and doing basically knowledge transfer. And so the exercise of translating those concepts into a framework like Julia that some of these technical contributors are more familiar with and excited by was a perfect opportunity. And then we see this as they're working through that, they get to then sort of try to break some ground. The challenges of just generally translating GDS into software, uncovering Julia-specific challenges earlier on, and just kind of getting the road, getting rubber hitting the road on getting Julia done. Yeah, so basically, Julia launched because there were a few people that I had been talking to that were excited by the possibility of cadcad and Julia existing. Me letting on that, hey, it actually does exist, but it's been basically abandoned. If you're interested, this is the way to get joining. So we love when initiatives just follow the demand from the community. So if you have ideas, socializing them, talking about them in the repo, not the repo, sorry, the Discord, is a great way to get things started. So kind of ties back into the bounties and the proposals concepts that we're dealing with. Yeah, and so if you want to kick things off, well, so the goals of cadcad, let me get there first. So it's a performance-oriented framework for production-level workflows. We also want to aid the transition from an expression-focused framework that is reference into the performance-focused one. We see basically a way for people to graduate on a certain sort of like track, if you will, if they're coming in from more of the Python world and they want to get into more sort of production workflows for this sort of stuff. Like this is a pathway we want to enable, and so we see that as basically being a function of the project that they're working on, the demands of its scale up in some way, or over the course of mastering, and building up the intuitions for modeling generalized dynamical systems, that they don't need as much handholding on like the UI UX of the APIs, if you will, and they can just focus on a framework of taking the thing that they understand and just making it run really fast. Ideally, we'd love for the Python-based model to run in cadcad.jl, but it's very likely that we'll need a sort of separate effort for transpiling, and because we'll have sort of the designs figured out in reference and embody them in Julia and potentially in Rust, the transpiling should be not too difficult of an effort, and to transpile from Python into Julia, and then maybe transpile from Python into Rust in time. So those are the goals of the effort. Where we are at the moment is We did a soft kickstart with Barton, who's been active in the Discord as of late. He's been very excited by starting to work on this. So had a kickoff with him and another contributor, Eugene, and we've opened the repo. They can get started to see where things are at. They can look at reference. There's also the generalized dynamical systems paper. There's some old requirements that we had gathered even before starting work on reference as to what we wanted reference to be and what we wanted Julia to potentially be. And so between those, basically start the onboarding of consuming the documentation. And then the next step is to build sort of a proof of concept of what a model would look like in Julia if you had a framework. So we'll have sort of like a target of what the experience might want to be, and just start iterating against there. So we've just kicked off the project now. And if you're interested, the best person to get in contact with is Emmanuel. He's basically the technical lead for cadcad, and to contact me as well, as I'm just sort of like minding the operations and ensuring that people with certain questions get routed to the people with the answers, or just ensuring that things are happening and people that are looking to do cool, fun stuff get the support they need in order to make that happen. So I hope that the sort of like launch of Julia is sort of, in a meta sense, a demonstration of how we can start getting projects done in cadcad as an organization. Cool. So any questions, thoughts? This is sort of the end of my presentation, and we're about at the half-hour mark. Yeah. Excellent. Thank you. Anyone else? Comments, thoughts, shout outs, questions?
Maybe just an observation.
Yeah.
If any of you enter the repo for cadcad.jl, the Julia that is currently there was done with a legacy cadcad in mind. So the cadcad.jl we are starting now is going to be a complete rewrite
Totally
of the
different thing.
Yeah, totally different thing, because the concepts got changed a lot. So the Julia that is already there is going to be completely scrapped, right? Just to keep in mind, you guys don't have to focus on what's already there.
Cool. I'm really interested in contributing to that, but I just want to get a real good handle on cadcad reference and what is meant in this paper by generalized dynamical systems. So I guess my question is...
Emmanuel's your guy. Yeah.
Yeah. What is do I just read through the reference code and the this wiki page of content and easy to categorize? Is that the best way to do that, or is there...
Right. So I would start by trying to read the GDS paper and try to get a grasp about GDS, because unfortunately we should have by now some sort of technical documentation to onboard new contributors, but we don't, unfortunately. That is something I'm going to work as soon as possible, because the problem is the way that the source code is on the refs implementation. Of course, you are welcome to read it. You are welcome to clone and experiment with it. That's totally fine. But the way that the code is now, because we wanted to, for example, have spaces as types in Python, we wanted to give some static analysis guarantees to the user, as I said before. The code may be a little convoluted. It's not very straightforward. But by all means, try to read the code. What is most up to date is on the master branch or on the main branch, the spaces.py file. That's what is most current right now. And but we need a documentation of onboarding that actually laces up both the GDS mathematical framework with the implementation choices and implementation that we have on the reference implementation repo, right? But right now, before we have that, by all means, read the repo, mainly the spaces.py file and the GDS article. Yeah, and whatever doubts you have, like don't feel intimidated by the formality or by the craziness of the implementation. Just ask me questions.
Cool.
We have messages here.
Yeah, I won't be intimidated by it. But yeah, okay. I Chris mentioned. I guess we spoke about that documentation problem yesterday.
Yeah.
So that's kind of. I mean, just my experience with like big projects is like it's easier to just get into documentation first and get a handle on what the hell's going on and like clearly articulate how to do something. So that's kind of what I'm interested in contributing to, and then like transition to doing working directly on the code.
Yeah, exactly. I mean, basically announcing cadcad Julia is us going 0 to 1 in terms of getting that first outside contributor that isn't like part of Block.Science in some extremely direct way. And so it is pretty explicitly like dealing with the growing pains to become more in the shape of the project that you're referencing in terms of like having onboarding docs and things. Because right now it's all tribal knowledge.
Cool.
Yeah. Cool. Excellent. Anyone else?
Yes. Regarding like the mathematics around complex adaptive dynamic systems, as I understand it, requires some knowledge of linear algebra and ordinary differential equations, and perhaps also partial differential equations. It might be hard to generalize, but for token engineering and tokenomics projects, which would you say are some of the like mathematical skills that are needed to understand not only the code but also like the essence of how to basically create a model or an equation that can be understood by other people outside of code. Does that make sense?
Let me try to rephrase to see if I understand. Are you asking what is the base level of knowledge required in order to do token engineering? And then sort of like the second part of that is like, is there a way of doing it without math that might scare off lay audiences so that you could communicate the concepts to lay audiences? Is that
the first one? Yes.
Okay.
Not to shy away from any math. I certainly want to learn everything that's needed. I'm not scared of. I mean, I was an applied mathematics major. I just need to brush off the rust out of it. And for the second one, I guess like outside of learning how to do the code, it would be useful to know how to express it in mathematical symbols. So
got it. Okay, so I guess on that front, there's a few projects that Block.Science had done that are open source and they're in cadcad demos repo. I'll have to find the specific link because there's actually a deprecated branch of it. So I can follow up with that. And in there, you'll have a Uniswap model. And you'll also have the Rye model as well. So like you could look at exactly those projects and see like the level of sophistication required to do like sort of like almost canonical examples at this point.
Okay, good. That works. Thank you.
Yeah.
I also just linked a book that we're using in that.
Yeah. The Milne.
Yeah. It's introduction, modeling, and analysis of complex systems. It doesn't explicitly teach you how to do differential equations and things like that, but they're in there, and you can refer back to wherever you need to.
Yeah, please shoot it my way. I understand that. I don't expect to. I understand that it's outside of the scope of this, but I do want to learn the basics so that I can do this correctly and at the highest level that I can.
Yeah.
Or they.
No, this is great. I mean, this is exactly why like that cadcad wiki effort was started, was because like there's a bunch of like related knowledge bases that you benefit from having in order to be highly successful here. So if you look at the text chat for the community call, that's where Brock has shared the link.
Thank you.
And then he's tagged you, so you'll find it easier.
Cool.
Thanks, excellent. Anyone else?
Just one more thing. I think I tried to reach Emmanuel by a direct message. I'd appreciate if he'll accept my friend request, so I'll be able to reach him in terms of cadcad Julia. Thanks.
Got it. I would actually recommend maybe like in the future, the best way is probably just like if it's to work on like core technical stuff, going right into the core tech channel. You can tag people there directly, and the additional benefit of that is I can have eyes on it. So if like you haven't gotten a response back, I can make sure like things like that. But obviously you can move to DM. Pretty clear that like it makes more sense to take it there. But I just generally find like at least in Discord spaces, doing it, reaching out to someone publicly usually gets just has more eyes on it outside of just that single person. It's like Discord is super noisy for whatever reason. They haven't figured out that like if you have a central panel to just like adjust your notifications for everything, people could like more easily manage notifications. And so like it's kind of like a deluge. So some people just turn off all notifications. Other people just get swamped in them. So DMs can be a little tricky.
It's tricky because the add here command sends a notification to everyone that's online, and the add everyone sends a notification to everyone on the server.
Yeah.
So there's sort of like no middle ground. It's just like it's a rocket launcher or a bazooka.
Right. Take your pick. Yeah. Well, you can directly tag people.
I mean, that's like by design, though, right? Like you can use roles and stuff, but that's work, and they don't.
And we have roles set up
to get blown up and get them back in the app, and great. All use time.
Goddamn product managers and their KPIs. We have some roles set up. I guess another thing to sort of touch on here is there will be some work in terms of a bit of the governance docs that exist in Repo. They're super stale at this point. We have the intention of just making it a little bit more legible in terms of like, hey, here are some key people. If you're interested in like getting more in touch, like these are people you can talk to about different things. So like highlighting Emmanuel's presence and role, highlighting my own presence and role, things like that, just increasing a little bit more legibility. as the community grows. Cool. Anything else? Otherwise, I'm pretty happy to wrap up. It's been yeah. So anything else? Cool. Thank you so much, everyone, for joining me today and participating in I think a really productive conversation. I'm really excited to see more of all of you participate in the Discord and help us really just build cadcad as not just a framework but as a community and all the things that are required there. So yeah, thank you so much, everyone.
Thanks, guys.
Thank you, Chris. Thanks.
Bye.
Bye.